Hi, good morning everyone, or good afternoon, or good evening, whatever time of day it is. It's Miss V here from New Orleans, and I'm ready to show you some stuff on Standard 11. Okay, so first of all, to get us started, I hope that everyone did well yesterday on your exam. Sorry for this whole mirror thing. I can't figure out how to flip the camera after I've already started the video. So this is what we're gonna have to do for a second. Okay. So I hope that you all did well yesterday. I look forward to coming back. Obviously, since I'm not there, I won't have a chance to grade your tests until I get back, but it's okay. Well, let's get started here. Today we're going to be talking about Standard 11, which is regression equations. Now, a regression equation, it's kind of an approximate relationship between our two variables. We've talked about linear relationships, right? And everything when we were creating a linear function or finding the equation of a set of data, a linear equation for a set of data, we were talking about exact relationships, okay? This slope here, the rate of change, so slope is the same as rate of change. The rate of change was exactly the same. So when you went from this point, rise over run, to this point, rise over run, to this point, that rate of change was constant. It was exactly the same because all of the data that we were talking about was exactly on that line. Now, when we're working with real data, that's not quite how it works. Okay, so when we're talking about real data, you might get points that are kind of like this, okay? Where you can see that they kind of follow a general slope. They're kind of going generally in the same direction, but it's not an exact relationship. We can't just draw a line through all of the points. So when we're looking at real data, the first thing that we do is we create a scatter plot, okay? So number one, we create scatter plot. Sorry about my thumb being in the way. Okay, so we create a scatter plot, and that's what this is. You're just plotting all of the points. Now, we're trying to find generally what the relationship is between whatever our x variable is and whatever our y variable is, between our independent and our dependent variables. We want an approximate relationship, okay? That's what a regression equation is. So the regression equation really is that approximate relationship between x and y, okay? Now you might have heard before of something called a line of best fit. I'll write this over here. Line of best fit. Now, a line of best fit is the representation of your regression equation, okay? The line of best fit says, okay, if I'm looking at this data, approximately which direction is it going, and do I have kind of the same amount of data points on the top as I do the bottom, okay? We can create a line of best fit by hand. We can look at it and we can draw the approximate line. We can make sure that we have the same number of points on each side. You can do that by hand using the line of best fit. We can also do this using our calculators. So you'll need your calculator today. If you don't have it, go ahead and pause the video and grab your calculator because when we're working with regression equations, we're going to be doing that on our calculators, okay? Okay. So let's get to it. When we find a regression equation, the first thing, like I said, is that we have to create a scatter plot, okay? After we create the scatter plot, then, well, really the next step is to find the regression equation, okay? We'll find the equation. Now, this sounds simple enough, but there's quite a few things that we need to do on our calculators. So, the first thing that we need to do is, in order to create that scatter plot, we have to put in our table of values, okay? So, let's see, turn this on. we're going to hit stat on our calculator, and you see how it takes us to edit. Hit okay, because we go to edit. Okay, now this right here, L1, L2, L3, that's list 1, list 2, list 3, and so on. Okay, so we're going to use the data that's in this table here. Okay, and it's the percentage of Americans diagnosed with diabetes by age group. Looking at this table here, we have each age group listed on the left, and then we have the age used to represent the group. Okay, so because in our calculator we can't put on our list here, we can't put for list 1 30 to 34, 35 to 39, because it's not going to give us the regression equation. We'll have an error. So we're going to use these ages in the second column that are used to represent the age. Okay, the numbers used to represent the age. So in list 1 here, we're going to input all of these numbers. Okay, so take a second to input these numbers here into your list 1. Okay, so you should have list 1 input. Okay, we have all the way up to 72 inputted here. Now we're going to take the percent, and we're going to input the percent as list 2, just as the numbers as they are. So 6, 8, 10, 12, 15. Okay, so we have our list 1 and our list 2. Okay, so finding regression equations. Number 1, we're going to go stat, edit, and then create our lists of data. Okay, that's the first part. Okay, now if we graph, oh, my window, is too large. I'm going to reset this. Hold on just a second. Oh, sorry. Okay. So we're not quite ready for that yet. All right. So we're not going to graph yet. I'm sorry. We have our 2 lists of data here, which means that we would have a scatter plot. Okay. But what we want to do is we want to find what that regression equation is. So we're going to go over here to stat again. Okay. Now here we see that we were in this same menu when we went to edit, but this time we're going to go over to calc. Okay, so if we go to calc, we're going to head down here to number 4, which is our linear regression. Okay, so we go down here to number 4. This is our linear regression. Okay, we're going to hit OK. Now my X list, what are my X values? Looking back at our table, we have the age used to represent the group, and we have the percent. So we have to think which of these 2 things is our independent variable. Okay, you're probably right. This is our independent variable. This is our dependent variable. So our independent variable is our X values. Now, if you remember on our list, this was list 1, and this right here was list 2. Okay. So we just check this. We have our X list is list 1, our Y list is list 2. Okay, and we hit enter, enter, that's good. That's all good, we don't have to do anything else. We hit calculate, Okay, now it gave us these numbers. Okay, now if you notice right here, this says y equals ax plus b. It says that a equals this and b equals this. What that means is that if a equals, we're going to say 0.46 and b equals negative 9.2, this was using y equals ax plus b. This was using this format, okay? So the calculator's saying, hey, this a value is here. That's our slope. This is our b value. So my equation is y equals 0.46x minus 9.2. Okay? This is our regression equation. Okay? So when we put this into our calculator, after we hit stat edit, create the list of data. Number 2, our second step, we hit stat, and then we went to calc, and then we went to number 4, which was linear regression. And then we hit calculate. Okay, after we hit calculate, we had to take our A and B values and put them into the equation. Y equals A, B, whoops, sorry, AX plus B. Okay, so this is how we use our calculator to find the regression equation. Okay, now what you know about linear models, actually it's this part right here, it's the one right above. What we know about linear models is that we can also take the information that we have here and find a linear model. Okay, this information represents a bunch of different points. Okay, so we're going to take 2 of these points. I think I'm going to take this one and this one. Okay, I'm going to take these 2 points. So I'm going to use the points 4210 and 6220. Okay, now using these points, I'm going to find a linear model. Okay, so y2 minus y1 over x2 minus x1. I need to find my slope first. So let's see, I have 20 minus 10 over 62 minus 42 equals 10 over 20, which is 1/2. Okay, or I could say 0.5. I might just do that, 0.5. All right, now y minus 10 equals x minus 42. Okay, equals 0.5x minus 0.5 times negative 42, that's half of negative 42 is 21, plus 10, plus 10. Now I have y equals 0.5x minus 11. Okay, so the linear model, y equals 0.5x minus 11. Okay, now again, you could have picked any set of points here. Okay, you really could have picked any set of points. They're about the same. So it doesn't matter which points you pick. Okay, either set of points is fine. Okay, so if we look at our 2 equations here, What do we notice about them? You see that here, when we found a linear model based on 2 of the points from the table, we had an equation, in this case, of 0.5x minus 11. When we input the information into the calculator, we had an equation of 0.46x minus 9.2. So you notice, looking at these two, they're fairly similar, okay? They're fairly similar in what we see. We can go into our calculators here. If we hit y equals here, we can input both of these equations. So our first one, y equals 0.5x minus 11, and our other equation was 0.46x minus 9.2. Okay, so once we put these two equations into our calculator, we can graph them. We can hit graph over here, and we can see what they look like. Now, our window is a little bit, I'm going to zoom out a little here. Okay, because I want to be able to see these. So when we're looking at these, in my case, the blue one was our linear model, the red one is the regression equation. But if we look at these, they're fairly similar in how they represent the data that was given, okay? So basically, when we want to find an approximate relationship between our x and our y's, what we're looking to find is a regression equation. Given what we know about linear models, we can take any 2 points and find a linear equation, okay? That's an approximation based on the points that we pick. The difference with using the calculator to find the regression equation is that when we use the calculator to find our regression equation, what we're actually doing is finding a more precise line of best fit that represents our data, okay? In order to do this, we plot our points, then we create our scatter plot within our 2 lists, and then we use the calculator function, regression, linear regression, in order to find our values for A and B, which essentially make up our equation, our regression equation, okay? All right, now there are 2 items for you to try here. I have to head off to a meeting, but I will post the answers for these a little bit later today so that you'll have those and you can see how you did. Okay, have a great day. Bye.